So now we're going to explore the reader interface and the writer interface and just kind of look at how this is all working here at IO Copy. Because in our code, and if you want to take this whole course, bada boom, bada bang, greatercommons.com. Right here is the intro to the language. Right here is WebDev. In our code right here, we had IO Copy, and we passed in a new file as the destination. So the destination is this right here, and it says we want a value of type writer. That's kind of a funny thing to say. We want, Roxanne, a value of type writer. That's kind of a funny thing to say, right, Jasmine? We want a value of type writer, and here we want a value of type reader, and here we had a string, and we called strings new reader. Okay. So let's look at first what a value of type reader is. Because here, if I look at, I'm just going to make a copy of this. That's not going to work. And I'll do it all right here. Delete the below. If I look at what is func.printf %t \n, and we're going to pass in str, what type is that? What type is that? It's going to be type string, right? And if I get this, I'm kind of curious what this will do. And pass that in, we'll see what that does. Now let's run it. So we have string, and we have a pointer to strings.reader. Interesting. So this needs to take in a reader. What is a reader? What is type reader? So if I click on this, I get type reader is an interface. We created interfaces. What's an interface say? Hey baby, if you got these methods, then you're my type. Remember? Do you want to see me pound out a little example? Type person struct first string type human interface speak, and then func person speak okay, and then I could say also func talk, I don't know, takes in a human, and since every human has the method speak attached to it, I could call that method off of the human, and then I could create a person. Is going to be composite literal, which is the type, and then the curly braces. And now that's going to have, I could go to talk, and I could pass that person in. Talk takes in a type human, and so talk takes in type human, and a person, since a person has the speak interface, And the human interface says, or the speak method, the human interface says if you have this method, you are also this type. Then anything that is going to be of type person will also be of type human. So anything that asks for a human, we could pass it in. And then we could call the methods that are defined, required, implicitly implemented, right? The interface is implicitly implemented. We could call those methods off of that type. So that's cool because we could also have type secret agent, which implements the speak method. And then we could pass the secret agent into talk, because if secret agent has the speak method, then it's also human. And so anything where a human is needed, we could pass it in. And the implementation of speak can be different for every implementation, right? So if we had type secret agent, and if type secret agent is a person, but also licensed to kill bool. So this is an embedded type, and embedded types are promoted. The inner type is promoted to the outer type. So this is the inner type, and then we create a secret agent. Composite literal is the type, curly braces, and now populate it. And we have person, colon, person, curly braces, comma, LTK, bool, true, comma, and then this would be first, and it would be like, I don't know, Jenny. And then that secret agent could also be passed into talk because we have type person, type secret agent. And person implements the speak, has a speak method, and secret agent has a speak method. And anything that has a speak method is also going to be of type human because it implicitly implements the human interface. So anything that asks for a human, you could pass in either a secret agent or a person. So talk asks for a human, so we could pass in a person there, or we could pass in a secret agent here because they're both humans. Why are they human? Because they both have the method speak. So an interface says, hey baby, if you've got these methods, then you're my type. That's kind of a funny joke, right? You guys aren't laughing. That's just the language. That's the language. And so it brings us back here to this reader. And when we look at the reader, we see that the reader is an interface. And the reader says, hey baby, if you got this method, then you're my type. What is that method? It needs to be a method called read, which takes in a value of type slice of byte. Sid, what's up, baby?
Sorry about that.
Good to see you, man. You're going to be watching some videos. You got a little catch up to do.
Yeah, I know.
So reader interface says you have this method. Its identifier is read. Its parameter is that it takes a value of type slice of byte. That's a slice. We know what slices are. We know what a byte is. It's 8 bits. There's a type in Go. There's a type in Go. Called a byte. So we're asking for a slice of byte. It's a rune is an alias for an N32. A byte is an alias for a uint8. It's an unsigned. U stands for unsigned, which means it's going to be positive numbers. Signed, here's negative. 2 positive, right? So that's a signed one. This is unsigned, so it's just the positive numbers. There's no negative. That's why it's called uint8, right? And it's 255 because we're talking about 8 bits. That's what a byte is, a uint8. And with 8 bits, how many possible combinations do we have? let me ask you this. With 1 bit, how many possible combinations do we have? A porch light. How many combinations? How many states does a porch light have? 2. If it's on, come trick or treat. If it's off, go away. If I had 2 porch lights, how many messages could I store and convey? How many different states of 2 lights do I have? It's 2 to the power of n, so it's 2 to the power of 2 is 4. If I have 3 lights, it's 2 to the power of 3. 2 to the power of 3 is 2, 2, 2. 2 times 2 times 2, that's 8. So I've got 1 light, 2 possible combinations. 2 lights, 4 possible combinations. 3 lights, 8 possible combinations. 4 lights, 16 possible combinations. 5 lights, 32 possible combinations. 6 lights, 64. 7 lights, 128. 8 lights, 256. 0 to 255 is 256 different digits. That's why that's 0 to 255. That's why a uint 8 can store the decimal numbers 0 to 255. It could represent those numbers in binary because there's 256 possible combinations, arrangements of on-off states with 8 light switches, 8 light bulbs, 8 circuits, 8 transistors. So we've got a byte. We know what a byte is. So it's a slice of bytes. So it takes in a slice of bytes and it returns an int and an error. Reader is the interface that wraps the basic read method. Read reads up to length p bytes into p. It returns the number of bytes read and any error encountered. So anything that has this method implements the reader interface. Let's look at godoc.org/strings. And we had new reader. New reader takes in a string and returns a reader, a pointer to a reader. Right? What are we wanting for? What are we looking for here? A reader. IO copy takes in a reader. This returns a pointer to a reader. Pointer to a reader. And for it to implement for any value of type pointer to reader to also be of type reader, what method does it need to have? It needs to have that method, right? And so where's that method? Right there. It has that method. Read, slice of bytes, return int, error. And because it has this method, it is also type reader. And so because it's type reader, it could be used anywhere a reader is asked for. Like right there. And we can look to see what does that look like. So here it is, its implementation. And we could click on it, and we could go to the code, and we could kind of see what it does. Right? Doesn't make much sense at this point. It's nice and concise code. But basically, it's doing the exact same thing that we were doing here with interfaces. So long as you have this method, and it could have different implementations for different types, then you're implementing this interface because you have that method. And so that allows us to have different things implementing the reader interface or the writer interface in different ways, and then being able to pass those into things that are supposed to read or things that are supposed to write. And so the writer also has a method. The writer interface has a method to implement. And the reader and the writer interface are ubiquitous in Go. So probably the first 2 big interfaces that you learn about. You don't have to know it for what we're doing. I'm just exposing it to you so that you don't look at this stuff. So that the point at which you say, I don't know what's going on there, doesn't happen here. But the point at which you say, I don't know what's going on there, happens here. Right? It's like you're just one level deeper. So long as you have got this idea that an interface creates a new type, and any other type that has the methods requested by that interface is also that type. So an interface says, if you have these methods, you're my type. You are also my type. And so both person and secret agent both have that method. So both person and secret agent are also type human. Okay? That's all you need to know for now.